Hello, today I'll try to solve all one data structure for from the scratch. So we have to design data structures that store strings, countability, returns and maximum and minimum counts. It has L1, it has increment, it has decrement, get max key, get min key. So the whole idea of building this structure, we obviously have to have a node, right? Class, and it's also, um, but starts from describing how it's gonna work in English. So we're gonna have internal store which is hash set, which will keep key like we have hello, right? Hello here. It will be key and result, it's a hash set, and result will be node, which gonna have a frequency, meaning 1 or 2 or 3, right? So this is the first storage we have, and second storage we're gonna have linked list of nodes, um, probably with head sentinel and some node like here, frequency 1, and it has set which is hello, then read code, right? And then we're gonna have tail sentinel. So every time, so this is in regards of structures. So what we're gonna have on increment? On increment, first we have to check if key is in store, and if yes, what we're gonna do, we gonna remove, if yes, we gonna get node, remove key from set, find or create node with frequency +1, add it to a set. Also 3 and 4, it will be if we don't have key in store. And similar we're gonna have on decrement, right? Similar we're gonna have an increment, find if yes, get not, find but with -1, add it to a set. So this is like similar and similar operation we're gonna have, and here we retrieve one key from max from tail sentinel, no, head sentinel next, and here we from tail sentinel prev. Okay, so this is our functionality in described in English, and in this case we're gonna have this is definitely gonna have O of 1. This is O of 1, 2. But this create, or this is definitely like common functionalities that can be find or create frequency, added to a set, and then there is a 5-step add it to a store, so by key, so it can be retrieved. But this is it does just different frequency used, right? So okay, so we're gonna have that linked list, and we have maybe we have node next. Next, then previous, right? And maybe frequency. Let's put 0. And we're gonna assign everything to it. Frequency equal frequency. Then self next equal next. I think next is keyword. Let's do it next. And self previous. So this will give us then here we have self store as dictionary hash set, hash table, right? And we also have here we have a self, let's call it words, or what is we accepting as an argument? Strings. Okay, let's say words, right? Okay, so we added store, we create self head as node with and then we have a set head tail. Right, previous will be float infinite. This will be infinite, and we can say that self head next will be tail. Self tail head will be head, and so on. So we created this list now. So we can say that self tail let's create variable like depth word. Yeah, word is fine. So we do self, and what we're gonna do, we're gonna say if words length of words more than 0, we return self words Okay, and then two important increment and decrement function. So the thing is that we have to create function that will be adding new node. So what we're gonna do, we're gonna say so we have to find frequency, right? And assume if k in this store, we assume that frequency will be 0, 1. We add in just one element did not exist. But if k in the store, frequency will be self-store key frequency, and it will be some different frequency, not just one. But what we have to add key. We're gonna call our function like add key, and or like say add key frequency, and we add key and our frequency to the thing. Imagine it will be functions that we will implement later. For this decrement, definitely key in store, right? So we're gonna have this frequency equals self store, but we have to okay, right? We have to not only add key frequency and node. Node will be head next, or head just starting node, or like next node, right? Then we can say node equal self-store key, and we also have to node words remove, right? But they will be different. They will be different. Okay, so let's do it like it's hard to think like optimization right away for that, how to optimize it. Let's don't do optimization at first. Just try to solve it. So we found our node in the key. Otherwise, it will be head node. But is it correct? Should it be new node with a frequency 1? And with next as self head next. Okay, let's keep it this way. So we add in frequency, we have a frequency and we have a node. Now, and we remove now we check if and yeah, it should be next. If node frequency next frequency equal our desired frequency. So this is the best case scenario. We just add and next words we add key and that's it. And we add self store key But if it's not equal, if it's less, no, because we see this is what could happen. We could have a head, then we could have two frequency and we have a 3 for example, and then we have that. So we have to find where we have to inject. And this is situation Then we have to wait. But I can just put else, right? Meaning if it's in store, we delete and that's it. Not the case. We still have to add it. But I have to add it after this, or it will be this, so I'm still adding add frequency after. And we add n, we add frequency, and we have key. And let's implement this function which accept node, frequency, and key. For that, we will create new node as node with frequency, and next will be return and next. So this is how we're gonna have it. Have a node, we create new node, like before we have node, and then tail node, right? And then we add new node, so our new node next will be node next, and previous will be just node. And then node next will be new node. And what we're gonna do, we're gonna add words add with key. And we do self store. Node, right? So what if we decrement? So we first read node. And we have the same set of operations. We got, we remove, we delete, we decrease. Then, if our frequency more than 0, right? This is the same thing that we're gonna have right here. So we had our node, we have our previous node, so we add frequency after previous node. So we insert it here. Yep. Line 27. Okay, let's do print operation. You know what? Can you go to my submission and grab print operation from here? So after adding this guy, I'm going to self print and say increment, then I'm going to add str. Oh, no, key. So something is not working. I don't know exactly why and what, but we will figure it out. No, does not repeat key. And it's line 41. Oh yeah, so this is gonna be frequency. We need frequency and we need list of words. Beautifully done. Beautifully done. Very nice. So what I get max key after increment hello, it's supposed to be hello. Why it's not hello? So far it's working great. It's just to get max, we have to have tail with wood. And here we have add next word. And next word. Get max key. Tail. Word. You see, there is a could be previous messed up because print is not relying on previous, it's just relying on next. Okay, so this is this function. We adding new using next, and we have the previous. We add with key. So how about we create to make sure that we are accessing correct one. Why is this one is empty? Okay, if we remove this here, we have to remove entire set. So if,
Табличку ставити, стрімання.